Hello everyone, and welcome to Water Activity and Cannabis webinar. Today's presentation will be 30 minutes followed by 10 minutes of Q&A. If you have a question during the webinar, type it into the questions pane, and you can submit a question at any time, and we'll keep track of these to answer during the Q&A. To answer our most commonly asked question in advance, yes, we will be sending out links to the on-demand webinar and the slides to everyone who attended today's webinar. Those will be available a day or two following the webinar. Today's webinar will be co-presented by Brian Rice and John Russell. Brian is joining us from Boveda, global leader in two-way in-package humidity control for cannabis products, musical instruments, and cigars. Brian is the head of R&D at Boveda with more than 20 years of experience in packaging and new product innovation, and is also a leading expert in water activity. He and his team have extensively studied the changes that occur in cannabinoids when stored at various levels of humidity and moisture, and he's going to share some of that expertise with us today. John is a longtime application support specialist here at Meter Group in the Aqualab division with 13 years of experience helping food and pharmaceutical manufacturers measure water activity to improve safety and quality in their products. In the past 5 years, he's worked extensively with cannabis processors to use both water activity and moisture content measurements to optimize moisture control in their drying and curing processes. We appreciate both of them joining us here today to share their expertise. And now I'm going to hand the microphone to Brian Rice, who will start today's presentation.
All right. Again, my name is Brian Rice, Director of R&D at Boveda, and I'll talk to you a little bit about maximizing cultivation profits post-harvest using humidity control. 4 points that I'm going to try to drive home today is first, we're going to understand how evaporation post-harvest affects cannabis, maybe gain a little understanding of water activity and the recognized ASTM measurement for determining cannabis safety. The third, what is the target moisture level for cannabis flower and understand how it directly impacts cannabinoids. And then 4, let's try to understand how those water activity levels to their sweet spot, which ultimately drives quality and economic gains. So who is Boveda? We are a privately held company founded in 1997, headquarters in Minneapolis, Minnesota, and we manufacture and produce two-way humidity control pouches that primarily serve the markets for premium cigars, music, and cannabis. Dive a little further down into Boveda's patented technology. Essentially, it's a very simplistic pouch. We use biodegradable craft paper. We take that paper and extrude a vapor phase osmosis membrane that's bonded to the paper. We then take that film and form it into a pouch and fill it with food-grade salts mixed with water and a little bit of gum to thicken it up. All three of those come together to combine and make our patented formula and pouch. So let's talk about what is a two-way humidity controller. Essentially what a two-way humidity control will do is will add in or remove water vapor as needed to maintain that product in an ideal RH. The water vapor can pass very quickly through the Boveda film to respond to the outside environment. Essentially, you can bring the contents and internal environment of that container to equilibrium, to whatever RH is printed on our packs. It's kind of like dialing in the thermostat. It's predetermined RH. It'll give off water and take water vapor in as needed to bring it to equilibrium. What Boveda is not is a one-way humidity controller. Essentially, it's not a desiccant, which is constantly pulling in water to create that dry environment. And it's not a humidifier, which is just the opposite, which is pushes that water vapor into the environment to create a wet space. So as you combine those two together and you've got the Boveda. All right, so now we know a little bit about what Boveda is, the pouch, and what a two-way control is. The three things that I'm going to touch on is how can you prevent evaporation of terpenes? One is within the terpenes is maintaining trichome health, and then also a monolayer water that is produced to help preserve and maintain your terpenes. The second is how do we control the moisture and weight and why it's critical to maintain this moisture and its economic impact. And then third, an overarching cannabis quality and making sure that your brand reputation is held by preventing mold and potential overdry buds and maintaining the fresh and safe cannabis. So in order to understand how to prevent terpenes from evaporation, we need to understand where terpenes actually reside. And the majority of the terpenes reside in the trichomes. And not only within the trichomes, they reside in the trichome heads. So in the upper left-hand corner, you'll see that the terpenes are actually reside in glands that are in the trichome heads. Along within that trichome head is also some cannabinoids, as well as the outside layer, if you would, on this trichome head is a slightly waxy surface layer. So now we understand where terpenes reside within a trichome. Let's look at what happens to trichomes when no humidity or without humidity control. So this is a snapshot or a picture of a zoomed up version of some trichomes on a specific strain. You can see on this picture that the trichome stalk is actually thinned out a little bit, which isn't bad, and also that the trichome head itself is actually intact. You can see it's maintained its shape, and some are translucent, some are starting to get cloudy. This looks like a pretty ripe and good trichome in bud. Now, this is a snapshot of that same strain. We're now looking at 1 month without humidity control. The heads of the trichome, that bulb shape, is now starting to shrunk. It's similar to what a grape does, transitioning into a raisin, and now the stalks have now started to dry up even further and started to twist and get a little mangled. This is leading down towards a very dry cannabis sample that probably will not be perceived visually appealing to any of your customers. And this is 2 months, the same bud, same trichomes on the same bud. Now the trichome head is not very appeasing, and essentially this is something that could happen within your bud as humidity control is not put in place, and a lot of these trichomes will fall off into the container, therefore creating the keef that's going to be sitting on the bottom. And I would assume at this point, after 2 months without humidity control, your bud is starting to turn into dust. So what's happening at this stage? We know that water evaporates out of the trichome heads, and along with that water, you're going to get the flavonoids and possibly some other cannabinoids are going to be exhausted out of the trichome head. It's very similar to if you have an open container or you have a bud and you open it up, that smell that you're going to get initially of a high terpene smell, that is terpenes that have been evaporated out of that trichome head, never to return back in. So overarching, how do we prevent evaporation of the terpenes? We do know that they reside in the trichome. So trichomes are brittle, fragile, and potentially have lost a lot of their potency. The ASTM standards are saying that we need to keep this cannabis between 55 and 62 to maintain not only good, healthy, and hardy hydrated trichomes, but they will remain flexible and preserve the cannabinoids all the way through from packing all the way to your consumers. So, yep, bad. That's a bad trichome. All right, so now that we understand during evaporation and how terpenes can evaporate through that trichome head, how do we protect this a little further? And what happens when your bud is being stored with a humidity control, and as your buds start to become into equilibrium with its outside environment, what's starting to happen is a monolayer of thin water is being formed around the trichome head. And essentially what it's doing is trapping and making sure that those terpenes and cannabinoids in the water actually within a trichome still stay within that trichome head, and they're only to be released once the consumer gets them and grinds it up and then releases that wonderful bouquet. What I like to tell people is essentially what that monolayer is a shield or a helmet that you're placing over that trichome head until it's actually consumed by the consumers. But this doesn't come at with a cost. And what's the most interesting is once this monolayer is formed, that smell that you're most accustomed to getting when you open up a container won't be there. I can tell you that's the absence of that terpene smell is good. That means that humidity control has been put in place. That monolayer of water has stopped any evaporation, and it is preserved and ready for you to, when the consumers open and grind your bud. And we've done some significant studies that show that there is zero terpene loss when this monolayer is formed. And you're also, by the way, going to keep these trichomes hydrated, healthy, and prevents oxidation moving forward. However, evaporation is still a problem. This is a study we did back in 2018. We measured multiple different cannabis studies across 5 different states and in all different types of styles of packaging, ranging from glass to paper to film, all different types of packaging. And reality is almost 90% of these fall below that 55%. So 90% of these samples that we tested in 2018 fell below that 0.55. This is dry weed. We actually, if you see some down there at the 0.44, those are the ones that you're probably going to see a lot of keep in your containers, and things are starting to turn into dust. So let's look at how evaporation can happen. Things that get out of your control when it gets to consumers. You spend all this energy in the production into the harvest, but what about this post-harvest? Humidity control can help in every one of these points. You've got almost, in this typical example, you've got about 8 different touch points post-harvest that once it's in the package, that evaporation can happen. So what happens when your buds are harvested to the farm and reaches your local dispensary? One, waterway is lost. There's a loss of revenue. Two, you dehydrated buds, you can be a loss of terpenes and cannabinoids. And three, overdry buds are going to compromise the trichome health and probably the overall quality. So let's look at several examples here. We've got 1,000 pounds of cannabis at standing price at this example, about $5 price per gram, and it starts at 50% humidity. Now let's look at what happens without any humidity control in a package. At a 5% drop in RH is roughly around a $15,000 loss just to water evaporation. Think of that, just a little bit of water, 5% of that water leaving is roughly about $15,000. And your trichome has been compromised. All the terpenes have been evaporated. The appearance is horrible. It's just some really horrible weed coming out of this without humidity control. And by the way, you're going to get slammed on social media. This is just a couple snippets that we've pulled out. People who are going back to the black market for dry bud. It's a hit and miss on quality. The weight is not exactly what's printed on the package. And by the way, it's just not a U.S. problem. It's problems to our neighbors to the north of us in Canada, as this humidity problem is evaporation is the problem. So as a cultivator, you're now down $15,000 just for that 5% loss. Dispensaries are unhappy because they've got really crappy weed. And by the way, the consumers aren't going to buy it. It's a lose-lose-lose without humidity control. So let's look at it. You can be saved. Now let's look at that same example. Your weed starts at 50%, same thing, 1,000 pounds, about $5 per gram. And now let's just look at if we increase this to 62% using humidity control. Just that 12% increase in RH is about $48,000 gain in revenue. And by the way, you're still keeping your cannabis safe. It's below a threshold where mold won't grow. Your trichome have now formed up monolayer to prevent any terpenes from evaporating and the cannabinoids from being lost. So as a cultivator, you've just increased your ROI just by using humidity control. Your dispensaries are happy and they're stocking and storing high quality bud, and your consumers are happy. They're going to keep going back to the dispensaries and buying. It's a win-win-win situation. So overarching, controlling RH maximizes your profits by one, you're going to maintain healthy and hearty hydrated trichomes. That monolayer is going to be formed, keeping cannabis safe and hydrated between the 55 and 62. And that monolayer water on the trichomes locks in those terpenes and cannabinoids until the time those consumers purchase it and grind it up. And then fourth, you're going to preserve the package weight, prevent mold, and avoid any costly recalls that could happen when it gets into the supply chain that you cannot control. And that's it. Thank you. And I'm going to turn it back over to John.
Thanks, Brian. You did a really good job of highlighting why it's so important to maintain the relative humidity in your cannabis and not overdry during drying and at post-harvest in all the stages of post-harvest. So I'm going to go a little bit more deeply into what it is that we're doing when we're maintaining the relative humidity in the cannabis and drying using water activity as a measurement. So the things that we're going to cover are microbial growth in cannabis and common molds that you see in cannabis. Also, we'll talk about how water moves, water activity, a mode of action, water activity standard methods, and also moisture content challenges, why it's difficult to measure moisture content in cannabis. We're also going to learn about cannabis isotherms, which show us the relationship between water activity, or RH, and moisture content, and also how temperature is a factor in that. And then controlling relative humidity in the drying process. So why do processors overdry? I think that it's pretty common that people know that you don't want to have bud that is too wet. So if you dry enough, you can avoid the microbial and mold issues that can pop up. However, if you don't understand what relative humidity is in cannabis, then it's difficult to know how dry you need to have the cannabis. So let's talk a little bit about microbial growth. There are specific measures for what we call water activity. Another way of saying water activity is internal relative humidity. So inside the cannabis flower, all those little air pockets inside the cannabis flower will have a certain relative humidity. That's going to be the same as the water activity in the cannabis plant material itself. There are certain levels of water activity where given microbes can grow. Now notice on this chart that the bacteria that we're worried about are above the 0.85 water activity level. Again, that's the same as saying 85% relative humidity. There are molds and yeasts that are going to grow in that area between 0.65 and 0.85 water activity, and 0.65 is the accepted limit for mold growth in cannabis. Most of your molds are not going to grow below 0.70 water activity. Some can grow down to 0.65, and there are a few others that can grow down to 0.60 water activity. And those are much less common and not really a concern in cannabis. So below 0.65 water activity is considered the safe limits for cannabis flower. So Dr. William Scott in the 1950s did some studies and showed us that there are specific levels for water activity below which microbes cannot grow. So the science has been done, and we know those specific levels like I showed on the chart previously. But it's water activity and not water content. It doesn't matter how much water is in the cannabis or in any given product, but it is a specific level of water activity that determines whether or not microbes can grow. So what are some common molds in cannabis? Aspergillus, Botrytis, Penicillium, Cladosporium, Mucor, and Rhizopus. Now, Rhizopus is especially a concern to me because I have a Rhizopus allergy, and I do get weekly shots in order to prevent reactions to Rhizopus. So that's one that's really important to me. And why do we want to avoid mold on cannabis? Well, it's true that when molds grow on your food, if you eat them, there are some microtoxins that might affect you health-wise, but overall, molds aren't going to get you sick when you ingest them. However, it's a little different when you inhale mold spores. So for healthy individuals, if you inhale mold spores and you get a fungal infection in your lungs, it could be much like a chest cold. It's not a big deal. But what if you're immunocompromised? Actually, a fungal infection to cancer patients or HIV patients or the elderly can be life-threatening. It can be very, very serious. So it's really important, especially since some of these patients are using cannabis for treatment. So why is it that water activity prevents microbial growth? So it has to do with how water moves. So water moves from high pressure to low pressure. Relative humidity and water activity are another way of saying vapor pressure. So inside any given microbe cell, there's a certain amount of water activity. And then there is the cell membrane, and the cell membrane maintains a certain turgor pressure. Now, water moves from high pressure to low pressure. So if the water activity outside of that cell membrane is higher, so in this slide here, you'll see that in the top left microbe cell, inside it has a water activity of 0.95. That's another way of saying 95% equilibrium relative humidity. So inside that microbe cell is 0.95. If the environment where that cell is existing has a water activity of, say, 0.98, then water will move from high water activity to low water activity till it comes to equilibrium. So water will actually move through the cell membrane as it tries to reach equilibrium, and that cell will then have what it needs so that it can split and create two cells, and then you have microbial proliferation. However, if the environment outside of that microbe cell is lower than 0.95, like in this example is 0.90, then water will move out of the cell and it causes turgor pressure loss. So what does the cell do? The cell wants to maintain that turgor pressure, and so it tries to adapt. So the microbe tries to adapt by altering its membrane makeup or by reducing its water activity to maintain turgor pressure. It will produce or transport in small solids to reduce its AW. And what happens when it does that? If it's unable to reach that equilibrium with its surroundings, then that cell goes dormant. Now, it's important to realize that when a microbe cell goes dormant, it doesn't mean that it dies. So if you are in your grow rooms or growing cannabis and bacteria or mold growth occurs, and the mold growth and micro count in general is too high, lowering the water activity isn't going to fix it. It's not going to kill those bacteria. What it's going to do is it's going to keep them from proliferating. It's going to keep them from growing. So you do want to be concerned with the potential for introducing microbes into the grow rooms. But if the microbe count is at relatively low levels and passing levels, then you lower the water activity in the dry room to where they can't grow, and you'll be able to maintain those levels. So, because of this issue with microbial growth based on water activity, there are specific government compliance parameters for a variety of different products that need to be kept shelf stable. Cannabis is one of those, and there are standards set up in order to help people be compliant. So one of the standards is for cannabis, and that is the ASTM D8196 for determining water activity in cannabis flower. Now notice that there are also methods for pharmaceuticals, for foods, for cosmetics, and this is a list of some of those methods. So there is a sweet spot, and Brian talked about this some. That space between 0.55 and 0.62 water activity tends to be the sweet spot, where the water activity is just right. Those moisture levels are just right. This graph here shows you water activity compared to moisture content. This is something we call a moisture absorption isotherm. And you can see in this moisture absorption isotherm, we can compare the moisture content to the water activity. And in that spot above the 0.6, 0.63, actually above 0.65, you're going to see potential for microbial growth. So we really want to be below 0.65. And a little bit lower is always helpful because you want to make sure that you're not going to have issues. You give yourself a little bit of a leeway, but you also don't want to be too dry. Brian mentioned how you can affect the quality of your cannabis if you go too dry, and also the profitability, and that's pretty important. So you notice that we were showing on that slide, on that moisture absorption isotherm, that there are specific levels for moisture content you can look at as well. And you can see that relationship between moisture content and water activity. So why not just test moisture content? Well, there are specific challenges associated with moisture content testing. And in cannabis, it's especially difficult to test moisture content accurately and precisely. For one thing, there's no standard to test against. Most of the moisture content testing for cannabis is done via a loss on dry method. In that method, you weigh a sample before drying, and then you add heat to dry a sample until it's totally dry, and then weigh it again. We make the assumption in the loss on drying method that all of the weight that is lost is due to evaporation of water. And because we know how much water weighs, we can then determine how much of that sample was water. However, how do you really know that something is completely dry? And the answer is we don't. And there's no standard to test against to show that the measurements that you're getting are true measurements. So there's no way of knowing that your measurements are accurate. And so because of this, there are many different methods that you'll see for loss on drying, and also for other methods for testing moisture content, like you may have heard of Carl Fisher. But each of these methods gives you different answers. You might see an oven dry method at 105 degrees for 2 hours, for example. Well, that's going to give you different results than if you're doing a loss on drying in an oven at 75 degrees and for a longer period of time. So really, it's difficult to know what is the true answer for moisture content. Also, you don't know if water is the only thing that volatilizes. This is especially important in cannabis because when you add heat to cannabis, you do cause loss of terpenes and flavonoids and volatiles, and so the weight that is lost is not just water. So using that loss on dry method, especially if you are using a moisture balance, adding high heat for a quick measurement in 5 or 10 minutes, then a lot of the weight that is lost is actually due to volatiles other than water in addition to water. So you also see a lot of imprecision with moisture content measurements. So even with a good calibration on a moisture balance, the best you can get with most any product is plus or minus 0.5% moisture content. And in cannabis, you often see plus or minus 1% moisture content. So there's a lot of trouble getting a precise measurement as well. So when we look at this cannabis isotherm again, and this time we're looking at water activity versus moisture content, you can see that that slope is relatively shallow, meaning small changes in moisture content show us large changes in water activity. Now with a water activity meter, we can get an accuracy of plus or minus 0.003 water activity, and you can get a precision of 0.002 water activity. So you have a very, very specific measurement. Now with moisture content, if you're getting plus or minus 0.5% or plus or minus 1%, then you actually are not getting a very good idea of what's happening with the moistures in your product. Okay, another thing to look at when you're looking at water activity is that water activity is temperature dependent. As a general rule, higher temperatures lead to higher water activity. Now, for any given product, higher temperatures will be consistent. The change in temperature based on water activity is going to be consistent for specific products. And also in cannabis, you'll see that higher temperatures lead to increased rates of decarboxylation. So what does this mean? This means we want to maintain a level of water activity or relative humidity in your cannabis flower even when it ships. So if it does experience higher temperatures, you may see higher water activities that may put you over the limit where you might have mold growth. So being able to protect that humidity level when it leaves your facility and before it's consumed is important. And also you'll want to be aware and give yourself a little bit of extra leeway. So being closer to the 0.6 or 0.62 is probably better than being right at the 0.65 water activity in case there is temperature abuse that the product experiences after it's packaged. Okay, so why do we want to control relative humidity in the drying process? And a lot of this has to do with what water activity is and what relative humidity is. We're going back to how water moves. So the mode of action for water. Water moves from high relativity to low relative humidity until it comes to equilibrium. Another way of saying high water activity to low water activity. So remember, if you're looking at 60% relative humidity, that's the same as saying 0.60 water activity. Relative humidity is expressed in a percent. Water activity is just water activity. It doesn't really have a unit, but we call it AW. So it's the water activity that determines whether or not mold, fungus, or microbes can grow. And it's water activity that determines quality, meaning chemical and physical reaction rates. So this is important, and we can go back to what's happening on the trichome at this, and at specific water activity levels, you get too low in that water activity levels, and it causes oxidation on the trichomes, and so you have a reaction that leads to loss of terpenes and cannabinoids. So if you're too high in water activity, then the challenge is that you're going to have fungus growth, yeast growth, or other microbe growth like bacterial growth if you're high enough. So maintaining that water activity is really important. Now in the dry room, it's important to maintain that humidity at a level where you don't overdry. So water will move until it comes to equilibrium. If you have the humidity in your room at 40% or 30%, you have the potential of drying your cannabis down to 0.40 water activity or 0.30 water activity. The other issue with having over dry environmental conditions in your dry rooms is that if you dry too quickly, the exterior of the bud can form a crust. We call it case hardening, in which case that can become a barrier, so the internal moisture is actually inhibited from moving through the bud and out into the environment. So you might have hot spots of high water activity in the bud, and you're going to have much less conformity in your room in the drying process. You're going to see a lot more variation in the buds in the drying process if you're drying in too low humidity. So being able to dry down to the right water activity levels and in conditions that bring it to the right water activity levels without overdrying is really important. So how to know when the moisture is right? Unfortunately, moisture content is not adequate. Why? Because it just doesn't have the precision or the accuracy. So when I look at water activity, it's a much more specific measurement. So it's like measuring to the nearest millimeter rather than measuring to the nearest inch. You know that you're right on spot if you measure to the nearest millimeter. Measuring to the nearest inch, you might be a little high, you might be a little low, and you wouldn't know. So that lack of precision becomes a problem for the moisture content, and you don't know if you're using a method or at a level of moisture content, because each method gives you different answers. You don't know if your measurement is really at the place where it's going to have the right water activity. So if you measure water activity to determine that your product is dry enough without being over dry, you can hit the sweet spot every time. Okay, so just to sum up, coverage that we want to dry to the right water activity levels to hit the sweet spot so that we're not over drying, causing quality loss, and also causing less profits, but also not under drying, meaning that you could have mold and microbial growth. Thanks very much.
Okay, thank you, Brian and John. And let's take a few listener questions here now. Again, there's still time to ask questions by typing into the questions pane, and we'll try to get as many as we can before we finish. So, John, first question for you here. They're asking, what's the best tool to measure relative humidity?
Okay, so if you're looking at measuring relative humidity in a dry room, then there's a variety of options available to measure relative humidity. If you're looking at measuring what is the relative humidity inside the cannabis bud, then we call that water activity. And the best ways to measure water activity in the cannabis flower, I tend to recommend a chilled mirror dew point sensor. The chilled mirror dew point sensor is a direct measurement of water activity or internal relative humidity, and it gives you very high accuracy, accurate to, depending on the meter you have, 0.005 or 0.003, and really good precision. It works very well for cannabis flowers, so that's what I tend to recommend. There are a few different options for chilled mirror dew point sensors in the Aqualab line.
Awesome. So yeah, if you want to know more information, we'll give you some links at the end here. Brian, here's another one. If I underdry my bud, will a Boveda pack increase the weight?
Yes, absolutely. And that's where that water activity measurement is so critical. If you under dry and you know where your start point would be, either adding Boveda Pack 4 specifically over the cannabis ones at 58% or the 62%, it will effectively bring up your cannabis to that equilibrium to hit that 62 or 58% mark. So whatever that difference is, you would definitely gain that weight back if it's over dry. It may take a little bit of time depending upon obviously how much the volume and the weight of the cannabis that's stored and how dry it is, but it will work and bring it back up, absolutely.
Awesome. Okay, let's see. John, let's go back to you. How would you measure water activity in a cannabis product that is in the finished product packaging?
Oh, so generally what we would do is remove a piece out of the finished product packaging. So water activity we do need to take out of the package in order to measure it. It's a very easy measurement to take. You just put a small sample into a sample cup and set it into a water activity meter and start a read. And for most products, you have a read in less than 5 minutes. So that's what you do is you would take random selections of your products and then measure them for water activity.
Okay, and about what size of a sample would be required for that then?
About 7.5 milliliters for most products. So not too big of a sample.
Okay, all right. We've got a couple of questions, John. They wanted some clarification on what you mentioned with the water activity instruments. You mentioned a chilled mirror dew point sensor. Can you go into a little bit more detail about those types of instruments?
Yes, absolutely. And if anybody would like specific details, feel free to send contact information to me and I can give much more detailed information. But to sum it up, what we're doing when we're testing water activity is we're taking a sample, setting it into a sample cup, and placing it into a small chamber. That small chamber has a sensor in it, and there are a few different kinds of sensors that you can get that will measure the relative humidity inside that chamber after it comes to equilibrium. In that small chamber, the humidity in the air above a sample is going to come to equilibrium with the sample itself. And so then if we can measure the relative humidity, then we know what the water activity inside the sample is. So a chilled mirror dew point sensor, you chill it inside that small chamber where the sample sits. You chill a mirror until dew forms on the mirror. And at the moment the dew forms on the mirror, take a temperature reading of the mirror and the sample, and you can calculate the water activity in that sample. It's the fastest method available for testing water activity. It's also the most accurate method that we have available, and it has a very consistent calibration. So you get a lot more consistency using a chilled mirror method than you do other methods. Other methods might include a capacitance sensor or a tunable diode laser. Capacitance sensor, you see a lot more variety. You also see changes in calibration over time with changes in humidity, and you need to do more to ensure that you're going to maintain that calibration. And also, capacitance sensors take much longer to come to equilibrium because it's not a direct measurement of the air, where a chilled mirror dew point sensor is a direct measurement of the air.
Okay. And where can they find those kinds of instruments for purchase?
Well, at Meter Group, we have a variety of options for water activity meters. And so I would recommend that you visit Aqualab Instrumentation at the Meter Group website, and I'd be happy to help direct anyone to that location if it's helpful.
Okay, great. Thank you, John. A follow-up for Brian on the increasing weight question. Brian, if you used a Boveda pack to increase the weight, then would this help increase the quality lost that occurred with overdrying or increase potency?
Yes, that's a very good question. I think if it is overdry, obviously those terpenes that were there when it is cured properly have been lost. So I think unfortunately a lot of the terpenes will be lost. So if you can prevent and kind of stop them from evaporating even further and getting to that monolayer is ideal. If we think about you were mentioned the THC, probably the potency. Bringing that back, it all depends upon the strain. We haven't done any significant studies to show whether or not we can revive and bring those back. But it is something that needs to be explored. It's all dependent upon the plant and how well it's grown and the genetics. So unfortunately, we could bring back the weight, but the potency of it may have already been lost.
Okay, let's see. We're running a little bit short, and we'll take one more question. And again, if we didn't get to your questions, and there's a bunch that came in, and we appreciate that, we do have them recorded, and we will be able to answer them. Either John or Brian or one of our team will be able to get back to you via the email that you registered with. So one last question. John, and then Brian, if you have any extra thoughts as well. John, measuring water activity, is there a difference between measuring the whole bud versus ground material? And then what about the situation you described with the case hardened bud?
Sure, that is a really, really good question. So a lot of times it's appealing to measure whole bud because water activity is a non-destructive test. And so if you can measure the whole bud, you can keep it intact. There are challenges when measuring whole bud, especially in the dry room, where the interior of the bud is going to be, it's going to dry at a slower rate than the exterior. And so especially if you've dried too quickly and you have case hardening, then when you're testing water activity, you may not realize that you are not in equilibrium in the chamber. So, so that can be a challenge. I do recommend breaking up the bud, and you can break it up either with a little hand grinder or breaking it up even with gloved fingers or a scissor to expose the interior. Then you know that you're coming to equilibrium in a water activity meter, and you're going to get the correct result. Now, when you go from the dry room into a curing process, if you're doing burping or you're doing curing in a bucket or a bag that's sealed, those buds are going to come to more equilibrium in the interior and the exterior during that time period of curing are going to become more uniform. And so then you're going to have an easier time testing whole bud at that step. Still, it's recommended that you would break open the bud and expose the interior so that you know you're getting the true water activity and not just the water activity of the exterior.
Yeah, I'd have to agree with you too, John. I mean, a lot of the testing that we've performed, not only just with cannabis but with hemp, you're going to get the true water activity meter reading in your meter if when it's ground up, and that is typically how the labs test for the COA. They'll take those buds and and this is a term that they'll use is homogenize the sample, and when they're homogenizing it, you're grinding it up to expose all that the water that has become into equilibrium. So I agree with you 100%.
Yeah, thanks, Brian.
Okay. Thank you, Brian. Thank you, John, again. And thanks to all of you who've attended. We've had a great attendance rate. This has been one of our highest percentage-wise attendance rates, and we know that this is important to you in the cannabis industry. And we hope you enjoyed this discussion, and we hope to have more in the future as well. So please visit metergroup.com and bovedainc.com for more information on Meter Group water activity instruments and for Boveda packs. And come find us at MJ BizCon. And within the next couple of days, we'll be sending you an email with links to this recording as well as to the slides. And if you're interested in further webinars on shelf life or other things of that sort, please be sure to let us know in the post-webinar poll that will pop up after you close out. And again, thank you, and stay tuned for future Meter Food webinars. Thanks, and have a great day.